All right, welcome back. We're gonna do some more torque problems on this video. So I left you with this one to do on whiteboards, and I wonder how you did with it. I don't have a calculator. I guess I could use a calculator on my phone. So I'm just going to kind of show you how to do it, and then you're going to have to do the math. This one was a little bit more challenging. Okay, so we had a wire holding up this beam, a beam, and a weight. So three things were causing a torque. Remember, the first thing is to pick a fulcrum, and I think it's kind of obvious the fulcrum would be right here. So this would be our fulcrum spot. So the reason I made a mistake in the last video is I don't do the sum of the torques equals 0. I just do the clockwise equal the counterclockwise. Then you don't have to worry about negatives. So I'm just going to do that this way, and you can do it either way. Okay, so if I do clockwise torques equal counterclockwise torques, I think you can see that this rope would take this fulcrum, and if you pulled, it would bend it counterclockwise. So I have a counterclockwise torque from the wire. That has to balance out with a clockwise torque from the beam. If you let go of the beam, it would fall clockwise. Plus a clockwise torque from the weight. Okay? So, torques are force perpendicular to distance equals force perpendicular to distance plus force perpendicular to distance. Okay, this is where it gets a little tricky and fun on this particular problem. Okay, so for the wire, here is the direction the wire pulls. Wires can only pull in the direction of wires. So the wire is pulling this way, and remember I said to draw that line long in either direction, and then the shortest distance that this wire is to the fulcrum is going to be this right here. Did I draw that? All right. Now, I'll leave you to do the math, but notice this is a 30-degree triangle. I mean, a right triangle here, right? A right triangle. If this is 30 degrees here, this is 60 degrees, and that's 90 degrees. If that's 60 degrees in here, and that's 45 degrees, and all three of these add up to 180 because it's a flat line, you can figure out what this angle is in here. If you can figure out what angle this is here, and this beam is L, then you can set this up in terms of L. You understand? Okay, so that's how you're going to do the force is your unknown, and that's how you're going to do the distance, this little distance right here. You're writing it in terms of L. Got that? Just text me if you don't understand that, and I'll figure it out mathematically with my phone and show you. Okay, now we have the beam. The beam, the weight of the beam is considered to be at the center of mass of the beam. That's going to be right here. And the beam is being pulled downward. So I go down, and I'm going to draw a long line in either direction, although in this case, I didn't really draw that straight down, did I? Draw it more like that. Anyhow, the distance of this force line to the fulcrum is this right here. And once again, you have an angle 45 degrees, and this is L over 2. So you're going to write the distance in terms of the 45-degree angle and L over 2. So notice now both these have L in them. You're going to see the L's are going to cancel out. Okay, my final torque is provided by the weight, and the force line is again straight down. You have a 45-degree triangle, and you have a beam of length L. So now you're gonna, the distance is the shortest distance between this line and the fulcrum. So that's gonna be right here. Boom. And you have 45-degree angle. This is L, so you're gonna write it in terms of L. And you know the weight, don't forget to add a 0, and the beam add a 0 because you're doing newtons, not kilograms. And then everything's going to have an L in it, so you can cancel the L out and get your answer. All right, isn't that a fun problem? I love that one. All righty. Next, I want to show you some flywheel problems. These are super simple. I'll turn my phone a little bit here. This is a bad drawing of a flywheel, but they're two concentric wheels. And there's like a rod in the middle, so it's like a little wheel and a big wheel. And you'll see these on multiple choice and free response problems on the AP exam. Super simple, and they can be more complicated than this. Okay, let's just do this simple one. This is actually an AP, let's see, I have it over here. This is an AP free response one, right there, that's what it really looks like, that I just redrew terribly. Okay, so there you go. We're doing this problem. So mass 1 is pulling this flywheel here counterclockwise. Oh, by the way, the two wheels are fixed together. So they don't spin separately. Okay, so this is wrapped around here and pulls the whole thing counterclockwise. And then this is wrapped around the outside and would pull it clockwise. So the clockwise torques have to equal the counterclockwise torques. We should have written that the opposite because this is the one causing it to go counterclockwise. So the counterclockwise force perpendicular to distance equals force perpendicular to distance. So this is the counterclockwise one, right? And the force is 200 newtons. And the distance is the distance of this force line to the fulcrum. Well, the fulcrum is the middle of the wheel, right? So if you draw a real long line here, the shortest distance is just the radius. So it's going to be R1. R1 is 0.5 meters. All right? That equals the clockwise torque, which the weight is going to be M2G, right? Be careful here if you're going to work with masses. You could just stay in masses and not convert that to weight. If you make that weight, you have to put a G there. If you had kept that mass, you could just do mass and it would work out okay because it's a ratio anyhow. So just be careful there. All right, and the distance is R2, which was 1.5 meters. What? And then you're just solving for M2. See, that's simple. 100 divided by 1.5 divided by 10. All right, that's how you do those flywheel problems. Okay, here's an assignment I have for you. Go get my big multiple choice Richard White problems of the day for one day, and I want you to go through and do the multiple choice torque problems. For most of them, the answer's in the bottom left, so maybe you can even give them to the substitute and have her put them up there, and so you're not looking at the answer, and then the next page has the solution if you disagree. You could do them in whiteboards or whatever. Okay, I have two AP free response problems that I want to show you that I want you to do also. Okay, so I'm just going to come over here and turn this around, and so you're just going to have to screenshot this. Can you see that? A rope. I'll leave it there for a second. You're going to have to screenshot that. Okay, and then the second one I wanted you to do is right here. I'm turning my phone, sorry. There you go. One more. Now that one you know is 2008 multiple choice number 2. Another torque problem. Alrighty? So that should keep you busy for a little while. And if you do the multiple choice problems, and now you've done some free response problems, that catches you up on torque a little bit. All right?